But today I'm having fun trying to make a shell, a spherical shell, but a shell that has another shell inside. This thing inside is going to be, let's see, it's 21 millimeters in diameter, and it has a shell thickness of 1.5 millimeters. So this inner sphere is 18 millimeters. I've already created the grid here, and that took me a long time. This actually took a long time to create a manifold. By manifold, I mean if you were like an ant, you could walk along every single part of this. That's you could walk everywhere inside the manifold. You can get from one point to another point without hitting a wall. And meanwhile, you could consider the whole thing could, like, you know, you could put it in water and there'd be no leaks. So an ant could walk through here while you put it through water, and the ant would never get wet. I guess that's one way of describing a manifold. I've never heard it described that way before, but that's what it is. It's all one open surface. The way the printer sees that is it says, oh, that's the part I'm going to fill in with material. All right, so what am I doing now? Well, I'm trying to take this and put a shell around the outside. And the hardest part about doing this for me is there's so many ways to do it. I can't even decide on which one. So I'm going to try one way, which is I'll create a sphere around the outside. I'll make sure it has a lot of segments, which means a lot of vertices. Okay, and I'm going to make that sphere big. So it's going to be, let's see, 56, 54 in diameter. Okay, so I don't know if you saw it. Oh, hello. I don't know if you saw it show up, but this is the new sphere I just created, this one on the outside. And so now it's a sphere within a sphere. And what I want to do is subtract. This is the part I don't know how to do. I want to subtract every part of this grid that is outside of this sphere. Okay, so what do? I can take this and subtract the sphere, and that'll get me the opposite of what I want. All right, I could take the sphere and subtract this, and that'll get me the opposite of what I want. I'm not sure how to do this. I'll have to come back in a second. All right. I took a couple sips of my drink, and I think I know how to do this. It's really hard to explain. I can't really use words to explain what I'm about to do. I'll try, though. I'm going to create a shell. This isn't a shell yet. I'll create one in a second. In fact, let me just do it right now. So to create a shell, I copy and paste. So now I have two spheres of the same side overlapping, same size overlapping. I'm going to make one of diameter 60. Typing with one hand, which really is not easy for me, but so now I've got two spheres. Here's an inner one, 54. Here's an outer one, 60. That's intentional. I want shell thickness here on the outside of 3 millimeters each. I've decided that's what I want for the material I'm using with my printer. I want there to be a 3 millimeter thickness. That actually might be too much, but I'm going to try that. Hopefully, I think it'll be easy to change later. Okay, so what do I want to do? I want to create a shell out of this. That's easy. Creating a shell out of this is just a matter of subtracting the inner one from the outer one. So I'm going to take this outer one and subtract it, or subtract from it the inner one, which is sphere 8. Bam, it's done. I now have a shell. Just to make sure that the shell, look, there it is right there. Just to make sure the shell is a manifold, meaning something I can work with, like an actual solid that can be printed. I go ahead and check it out. Look at all the vertices, clean up everything, and then make my manifold. And it worked, so now I have a shell. I can get rid of this original one and get rid of these things also. I could do this faster if I was typing with 2 hands, but I'm just using one. So going back to where we were, look at this. So what I have now is this sphere, the shell on the outside, okay, and this structure which has a shell on the inside. The shell on the inside is attached to the structure, so that's already a manifold, as I've already explained. And okay, so here's the trick. What I'm going to do is I'm going to find the intersection. I don't know if this is going to work, but it should. I'm going to find the intersection of, oh God, how am I going to do this? No, I'm not going to do that. I'm going to subtract the shell from the grid. And then after that, it's hard to explain, but you'll see what I'm going to do now. So I'm subtracting the shell from the grid. Whoa! I have no idea what that was all about. My screen just completely blanked. Okay? This is what happens when you type with one hand. All right, so I'm going to subtract the outer shell, this one, from, it's easier to see this way. The outer shell, I'm going to subtract from this. So how do I do that? Break out my Boolean modifier. I'm going to take the difference of the Boolean modifier and the shell, which is called sphere 9. It's not really a sphere, it's a shell, spherical shell. Sphere 9. Subtracting the 2. Okay? So look what I have now. This should be kind of interesting. Hold on. Get rid of this. Ah! Jeez, I don't think it worked. No, it doesn't look like it subtracted anything. There's one way to tell for certain, though. If I highlight all the vertices, and I try to separate by parts, then it means it will have worked. Let's see if it worked. Did that work? I don't know if it worked or not. That's kind of what I wanted, but it's not the right size. How weird. It sort of worked. All right, well, sort of worked. So it looks like what I did actually did work. At least if it looks that way. I've got, this thing is spherical. It represents the grid that's going to support this inner shell. This inner spherical shell. It's going to support it, but it's going to be attached to an outer shell. So that's what that looks like. This I don't need anymore. Typing one hand. Gosh, I'm just really bad at typing with one hand. These things are centered. And so now what I'm going to do is try to combine them. So this thing is a shell. This thing I want to attach to it. There's no reason to think it's going to work perfectly, because let's zoom in here so you can see what I'm... zooming in is not easy with one hand. I don't know how to do it. I'm going to grab the phone with my teeth, or the camera with my teeth. Uh-huh. There, much better. So if you look at this area right here, the way that, you know, here's the outer shell, here's the inner shell, and you can see the vertices. These vertices have to find another set of vertices nearby in the outer shell for it to bind, for the algorithm to work and say, okay, I know what you're trying to do. Let's connect things and make a manifold out of them. Sometimes it doesn't matter how good the software is. It's just not possible, because either the vertices are in the wrong place or there's not enough of them. So I've got some work to do to make sure that's going to be okay, and I'll be right back. Okay, I tried the union again. This time I made the inner structure a little bit bigger. That way I could make sure that there is no big gaps between the outer part of the inner structure and the inner part of the outer structure. Gaps would mean that the vertices weren't close enough to connect, or they don't actually connect, they become one. To synchronize, what's the right word? I'm sure there's a great word. Synthesize. Okay, but now, it looks great, but I don't know for certain that this is going to be printable. So now I'm going to check everything. Once again, all the vertices, make sure everything's consistent, not weird angles, not things that penetrate geometry in ways that isn't realistic. This removes some duplicate vertices and hopefully fixes any problems that the union modifier created. So the check worked well, and now I'm making the manifold. I'm a little more optimistic this time. It worked. It worked. Oh, wait a second. I don't know that it worked. It doesn't look like it worked. Wait a second. Did it work? That looks okay. We're going to find out soon, though. The way to find out, it doesn't look good, but the way to find out is, let's export the STL, and this is just going to be, I'll just call it spherical, 60 by 21, and inner shell is implied. Whoop. 60 by 21. Export it. All right, here's how you test. Oh, something didn't look right with the way it's saved. Again, I can't type one-handed. Spherical. There it is. Let's see. So if it opens up and it looks okay. See, that looks okay, and then I can look at cross sections here. I think it's right. I think that's right. Yeah, that looks like what I had planned. And so what we can do is we can try to we can see if it wants to print it, and then we look at how the printer will actually work. Yeah, very good. That's success. That should be fine. That should work. Look at that. Look at that. Let me zoom in. This is one reason I like Simplify 3D, is because it gives you a much better view of what's actually going on with each layer. Cura does the same thing, but it's much harder to see in Cura. Oh, I got a problem. Uh-oh. This is printing out in the middle of space. Damn it. I forgot about that problem. This layer right here, right there in the middle here. Again, this layer right here is printing right in the middle of space, which won't work. I can put some lines here. That'll fix it. Okay, I'm going to try a trick here. I'm going to try something. I haven't modified anything, but I do need this part right here to be resting on something. How do I do that without adding support? I think I can just rotate the whole model. So let's try that. Let's go back to here. And I think I won't be able to see it as I do it, but I think I can rotate the whole thing. Not in that direction. I have to be... Shoot. Okay. Alright, I need to rotate it around the Y direction, and I'll do it 90 degrees. Scaling rotation. 90 degrees. Again, you won't be able to see it because it looks the same on the outside. Let's try it. Yeah. This is where simplified 3D is just kind of funny. Ah! It disappeared. Where'd it go? Underneath? That didn't make any sense. Huh. I just put it back to where it was and it went underneath. So that's just the simplified 3D has some issues just like all the other ones. Well, I can also rotate it around the X direction. Let's see what happens there. Same thing happens. Yeah. Well, that's okay. I can raise this. And since I'm going to add support underneath anyway, then it shouldn't be a big deal. The trick here is to make sure I'm pretty close. So it actually comes close to touching the bed. A little bit higher, a little bit lower. Pretty close. Pretty close. It's actually okay that it's not touching. All right, so now let's go back. Now I'll prepare to print again, and let's see if that's going to be resting on something now. Okay, here we go. Is it resting on something? Is that bottom part printing on top of something? Yeah. Look at that. It's printing on top of something. That'll work. I didn't have to modify the model. Success. This should work fine. It says it can take 3 hours to print. And I think I'm about to get started with it. Woohoo! Well, things went a little funny since I talked to you last. You know, just kind of funny. And I had a few drinks, including a snow cone. Homemade. And I got back to this, but I created a completely new design, which was kind of funny. But I did it. And the new design has a shell within a shell within a shell. I kind of went a little funny.
The bomb, Dimitri. The hydrogen bomb. Well, now, what happened is one of our base commanders, he had a sort of, well, he went a little funny in the head. You know, just a little funny. And he went and did a silly thing.
And I ended up with this kind of thing. But here's what's really kind of funny. This part right here, that's part of the design. That's actually, we went through that earlier, that is actually the grid of the object itself. That is part of the grid. These guys right here, this crisscrosses. But here's what's kind of funny about it. There's some crisscrosses here. That's not part of it. That's just infill. How and why are they the same angle? I have no idea. That's just kind of funny. Now we're back to our actual object. Again, same angle as the infill. Kind of funny. And then we get to our inner compartment. So what's going on here? Why did I do that? Well, check out this inner shell here. Check out the inner shell. It's got like no support. There's essentially nothing going on in that inner shell. It's hanging like by a thread. I think that's like a 0.45 millimeter thread. Why did I do that? Well, because this whole inner shell, this is going to be filled with lead shot. That's going to be supported, once you drop this thing, it's going to be supported entirely by this inner thing, which has no support, meaning it's going to bounce all over the place. It's going to move all over the place. Essentially, it's just hovering in the middle. Let's go up a little further. I want to see if we've got more infill here. Yeah, so all this is infill here. So there's enough of it that it shouldn't, well, it'll probably break. I kind of like it. What do you guys think? Orthogonal. Well, 45 degrees to the, well, it's orthogonal. Right. It's so anyway, it's 45 degrees to the structure. I think you can see that, right? So here's the structure, bam, bam. Here's the infill, which is at 45 degrees. This is, I think, going to be about 0.6 millimeter. And keep in mind that it goes all around that middle shell. It should be strong enough. It might break. If it breaks, that's good. That means I've done something right. It might even work better if it's broken. In fact, I've actually thought about just, if I could, just fill this inner area with like loose spaghetti. In any case, here's proof that Simplify 3D, this product that cost me 140 bucks, but I did it anyway. It's just better than Cura. It's better than Slicer, however they spell that. You can see what you're doing. It gives you all kinds of options. Each one has its own advantages, but this is such a great advantage. I just feel like I have way, way, way more control over what I'm printing here. Look at that! Wow. So I'll let you know how it goes.